will be high, and this causes direction of the airflow from this one to this one, and according to this relationship and formula. Okay, we should know alveoli are thin-walled, inflatable grape-like sacs at the terminal branches of conducting airways. Each contains single layer of the epithelial cell. Epithelial cells are two types. Type 1 cells for gas exchange, large and occupy 95% of the alveolar surface area. This cells is the name, another name is pneumocyte type 1. Another cell is type 2 cells. They secreted this cells surfactant. This cells is small cells, and another name pneumocyte 2. We are after, behind these cells alveolar macrophages as well. The pulmonary surfactant, okay, it is secreted by the type 2 pneumocytes and monomolecular layer distribute on the liquid air interface, okay, and its density changes with the changes and the alveolar volumes, and its function is mainly to decrease surface tension. Surfactant, it causes the decrease in the surface tension this here. 2% of total surface tension decrease. Physiological significance of the surfactant is this: it is beneficial to maintain alveolar volume stability. This is very important. It reduced interstitial fluid production of the lung interstitial tissue and alveolar cavity to prevent pulmonary edema, and it decreases, okay, in respiratory resistance and reduce in respiratory work and help pulmonary ventilation and lung expansion. Surfactant helps alveoli to different sizes remains inflated. Okay, it's very important substance. Surfactant can reduce surface tension, which or tries to make the alveolar smaller and keep alveolar pressure constant. Alveolar pressure constant. Surfactant is a complex mixture of the several phospholipids, proteins, and ions. The most important components are the phospholipid, the palmitoylphosphatidylcholine, and surfactant apoprotein as well, and calcium ions. The palmitoylphosphatidylcholine, along with the several less important phospholipids, is responsible for reducing surface tension. Okay, surface tension. You can see in this figure the surfactant metabolism. Surfactant precursor in the type 2 cells, and after that synthesis, this causes the exocytosis from the lamellar bodies from the tubular myelin in the alveoli. You can see this is the fluid, this is the surfactant, this is the air space in the alveoli. You can see location of the type 1 cell. This cell is very big cell, and macrophage as well is located in the alveoli. This cell is type 2 cells, and surfactant continuously synthesis and exocytosis and endocytosis and recycling or destruction of surfactant components, and renewed every time. Okay, renewed and renewed. The most important component is the palmitoyl DPL and DPPC. You can see the structure of the palmitoylcysteine and dipalmitoylphosphatidylcholine, and two palmitoyl residues of oily, water insoluble, hydrophobic, and other end of the molecule is charged. In this here is charged and water soluble hydrophilic. This molecule have a two side, hydrophilic and hydrophobic. Hydrophilic is contact with the water, hydrophobic is contact with the air, and this causes the prevention of the contact of the water with the air. This is very important, okay? You can see this here. Hydrophobic and hydrophilic. Hydrophobic is contact with the air, and hydrophobic is contact with the water. Alveolar volume changes without surfactant. You should know if surfactant lowers the surface tension of the alveoli and causes surface tension to change with volume. Then keeps alveolar pressure constant. Okay. Surfactant, for conclusion, reduces the work of the breathing, increases compliance by decreasing alveolar surface tension. This is very important. The quiet respiration is very easily. This because the surfactant is very important for the respiration. And work decrease, okay, and compliance increase. Alveolar volume changes without surfactants. For example, the surface tension of the alveoli would cause a small alveoli to empty into the large alveoli if it were not for the effect of the surfactant. In the clinic, the relation neonatal respiratory distress syndrome and RDS in the absence of the surfactant. In the absence of the surfactant, so you can see that after that, the lower the Laplace, this one, pressure, surface tension, and R. In the absence of the surfactant, in the smaller alveolus, the pressure is high. For example, is equal with this 6, and the large alveolus, okay, pressure is 3. This causes the airflows into the larger volumes. Okay, based on this formula, pressure is greater in the smaller alveolus in the absence of the surfactant. Okay, the pulmonary surfactant is the detergent-like substance secreted by the type 2 cells in the lungs and reduce surface tension at the alveolar air interface and interface with the hydrogen binding between water molecules. Surfactant lowers the surface tension of the alveoli and causes surface tension to change with the volume. Then keeps alveolar pressure constant, and we mentioned again. Alveolar pressure does not change, very important, with the surfactant, okay? Based on the law of the Laplace, this law, and the pressure, the surfactant produce surface tension, pressures is equalized in the large and small alveoli. For example, in the presence of surfactant, pressure in two alveolar is 2. In the this alveolar is as well is 2. Okay, small volumes alveoli have a small surface tension. Why? Large volume alveolar have a large surface tension. Okay, concentration of the surfactant in two these is not the same, and pressure was the same. These neighbors alveoli to unequal size to exist side by side and with constant pressure. Taken together, surfactant, interdependence, and the lung fibrous tissue are important for stabilizing the size of the alveoli. If some of the alveoli were small and others were large, theoretically our smaller alveoli would tend to collapse and cause expansion of the large alveoli. This instability of alveoli does not occur normally for the following reason. Interdependence, okay? The adjacent alveoli, alveolar ducts, and other air spaces tend to support each other in such a way that a large alveolus usually cannot exist adjacent to a small alveolus because they share common septal wall. Another is a fibrous tissue. The lung is constructed of about 50,000 functional units, each of which contains one of the few alveolar ducts and their associated alveoli. And all of them are surrounded by fibrous septa that act as additional supports. Finally, surfactant reduces surface tension. Okay, this allowing the interdependence phenomenon and fibrous tissue to overcome the surface tension. Surface tension effects. As an alveolus becomes smaller, the surfactant molecule on the alveolar surface of squeeze it together, increasing their concentration and thereby reducing the surface tension still further. Respiratory work done by that respiratory muscle overcome elastic resistance and non-elastic resistance to realize pulmonary ventilation. It is 3 to 5% of the total body energy consumption, and it is very small. But during the heavy exercise and in the disease, the amount of the energy required can increase as much as 50-fold, especially if the person has any degree of the increased airway resistance or decreased pulmonary compliance. Okay. Therefore, work of breathing or respiration compliance work divided 3: compliance work and tissue resistance work, airway resistance work. In the compliance work, that required to expand the lungs against the lung and chest elastic forces, called compliance work or elastic force. Okay, the most work, this is work, and the tissue resistance work that required to overcome the viscosity of the lung and the chest wall structure. Airway resistance work that required to overcome airway resistance to movement of the air into the lungs.